Okay, today we are going to look at permutations and combinations. And basically what that means, permutations and combinations are just a way of counting objects or something like that. So things to remember is that if we're talking about a combination, the order of the objects does not matter. Okay, the order does not matter. Okay, and then on the flip side, if we are talking about a permutation, the order of the objects does matter. So the first thing that we are going to do is just look at some examples, and we're not going to calculate how many things there are or anything like that. We're just going to decide, should it be, is that an example of combination or is it an example of a permutation? So if we look, we have alphabetizing books on a bookshelf. So think about that for just a second. Does the order matter if you are alphabetizing? Well, alphabetizing by definition is ordering, right? Which means that would be a permutation. Putting toppings on a pizza, honestly, it doesn't matter if you put pepperoni on first and then hamburger, or sausage then hamburger. It doesn't really matter when we're talking about just the toppings. So we'd have that would be a combination. A fruit salad doesn't matter if you put in the strawberries before the grapes, so that would be a combination. Choosing a combination for your gym locker, if you have a locker or anything like that, you know that you have to put the combination in the correct order, so the order does matter on that, so we'd be at a permutation. Making a license plate with 3 numbers, then 3 letters. Well, if we say it has to have numbers first, then letters, then the order does matter, which would mean that that would be a permutation. And then we've got choosing a random group of 4 people to be on your team for PE. It doesn't say they have to have certain jobs or certain roles or certain positions. It's just a random group of 4 people. So that means the order that you pick them doesn't matter. So we'd be at a combination. And then awarding first, second, and third place in a horse race, that is ordering, which means you are going to go first, then second, then third, so the order matters. So we are going to be at a permutation. And then picking 5 pairs of shoes from your closet to go on vacation. Doesn't matter if I pick my sandals and then my boots, or my boots and then my sandals. They're all going into my backpack or all going into my suitcase. So the order doesn't matter. So we'd be at a combination on that one. So go back and kind of think about those. If you're kind of confused, ask some questions about it or anything like that, about how to tell if it's a permutation or combination. So the good news is with permutations and combinations, we are just going to use our yellow scientific calculator in order to calculate these. Okay, so when you're calculating combinations, again with a combination, the order does not matter, okay? But you're always going to be given how many total objects you have and then how many you're choosing. So N, when we're doing combinations and permutations actually, is the total number of objects, or whatever you happen to be looking at. And then R is the number you are choosing. How many are you choosing? And on our scientific calculators, you're going to look, and I always say, all good things come from math. Okay, so you're going to hit the math button. You're going to arrow over to the probability. And then the third one down will have a C and a little N and an R. Okay, we are not using the Desmos scientific calculator, so we are not going to use that. So if we're looking here at an example of a combination, would be an ice cream shop allows you to choose 2 toppings from their list of 11 choices. How many ways could you choose 2 toppings? Well, we have a total of 11. We have 2 to choose, which means we would have 11 choose 2. So in our calculator, you're going to hit math, arrow over to probability, hit that combination button, number 3, okay, and you're going to enter it just like that. So on your calculator, it'll look like this, and it'll have a little box here, and it'll have a little box here. You just need to put 11 in that box for the total number, and 2 in the other box. And just practicing, if you did it correctly, you should end up at 55 ways that you could choose 2 toppings if you had 11 to pick from. Okay, then similarly with permutations, okay, where the order does matter. Again, this is the total number that you have to choose from, and R is the number you're choosing. Okay, again, on your calculator, same idea here. We're not doing Desmos, so I'm going to cross that off. you're going to go to your math button, arrow over to probability, except this time, instead of choosing the C for combination, you're going to choose number 2, which is P for permutation. And again, when you choose that, it'll bring up a screen on your computer or on your calculator that looks like that, where you're going to put in how many you have total and how many you are choosing. So in this case, if you have a permutation of 10, choose 3, you would have a total of 720. Okay, let's just look at a couple of more examples here. If you want to pause the video and try them on your own just to make sure that you're on the right track with choosing permutation or combination, please do. You're making a 5-layer cake and wants each layer to be a different color. If he has 12 colors to choose from, how many different layered cakes could he create? Okay, well, for making a layered cake, you have to put the first layer on before you can put the second layer on, before you can put the third layer on. So order matters. So if order matters, that means we're going to have a permutation. So in your calculator, you're going to have your permutation. You have 12 total, and you are choosing, how many are we choosing? We are choosing 5. So you do 12, choose 5 in your calculator, and hang on, I don't have that written down. You should end up with a bunch, 95,040 different ways that you could make that cake. Okay, so let's just, again, the practicing part of it is making sure we know whether we want to use a permutation or a combination. Planning a movie marathon for himself and his friends. He has 20 movies to choose from and wants to watch 3 of them. How many different movie marathons are there possible? Well, this is also the order that you choose them, because you don't want to watch the same movie more than once, is going to, so the order matters. So you're going to have a permutation. And your permutation, you're going to have 20 movies and you are going to choose 3 of them. So if you do on your calculator 20 with a permutation and you're choosing 3, you have 6,840 different ways that you could watch those movies. Okay, now we're talking Crayola. The box of crayons is making a specialty box of crayons to sell for Valentine's Day. They have 45 color options to choose from, but only room for 8 colors. Okay, how many different specialty crayon boxes could they make? Well, the order that they pick the colors doesn't really matter. So we're going to have a combination because the order doesn't matter. So we're going to use our combination, and we have 45 total, and we are choosing 8. So if we use our calculator, 45 choose 8, there are a bunch. There's 215,553,195 different ways that you could do that. Okay, and then the last one is a group of 9 friends all want to go to a concert, but they only have 5 tickets. How many ways could they choose who goes to the concert? So they're just randomly picking who gets to go. So the order that they pick doesn't really matter. So we are going to have a combination, and there are 9 friends and only choosing 5 to get to go. So if we put that in our calculator, combination 9 choose 5, there are 126 different combinations of friends that could actually go. So again, you're going to practice this on a class kick. It's called Permutations and Combinations. And the hardest part, again, is deciding which one do I want to use, permutation or combination. So you just have to ask yourself, does the order that I do that matter? Good luck.